Hi and welcome to this OCR Paper 4 Maths GCSE Higher Tier Prediction. Enjoy! Hi, welcome to this prediction from On Maths. Now, with this prediction, what we've done is we've looked at all the previous exam paper questions, seen what comes up regularly, what's long overdue to come up, and we've created this predicted paper. Now, this predicted paper you can also do online if you click up here, and it's completely for free, and you can even sign up to save your scores. Now, the online version will change the numbers each time you do it, so you'll get a unique experience. You won't just remember answers, but the methods you'll see in this video, you'll use exactly the same. We've also got topic busters on the site, which are just focused on a specific topic, and we've got them for all the Maths GCSE topics. We've also got videos on this site for every single type of exam paper question. And also we've got the revisionator on our site, which is for short, quick revision. So if you've got 10, 15 minutes and you want just a completely random selection of questions, then please go and check that out on our site. Now, as we always say with these videos, please do not fully rely on this as your only revision strategy. Please do this alongside all your other revision for these reset papers. If you've enjoyed this video, please click like. And if you want to see more from us, especially Paper 2 and Paper 3 coming up very, very soon, please click subscribe. Enjoy. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now 1.42 divided by 1 is just 1.42. So the problem with this question though is that it wants the answer in pounds, so we'll need to convert both of these things into pounds. So we're actually going the other way. And when we go the other way, instead of times we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000 and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8. Obviously to 2 decimal places, because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £1,112.68, and on my calculator I'm just going to type in 2,500 take away answer and then press equals, and it gives me the answer of 387.32. so it's £387.32 cheaper. Okay, so this question asks us to find all possible integer values. Now it's really important we understand that integer just means whole number, or whole numbers I should say. Integer is just a whole number, so we're looking for all the whole numbers that are between -2 and 4, and that's all this is saying, that x is anywhere between -2 and 4, but because this doesn't have a line underneath it, it does not include that number, so it doesn't include -2. This one, however, does have a line underneath it, so it does include 4. So the first one's going to be -1, 0, 1, 2, 3, and we include the 4, but we don't include the -2. So this is our answer. Okay, so whenever we're asked to estimate with a scatter graph, we're always going to start off by drawing a line of best fit. So I'm going to draw my line of best fit, and yours might be different to mine, that's absolutely fine. Now it's asking us to estimate the height and it's giving us the width, and that's really important because the width is up the side. So a common mistake would be to read 17 from the bottom, but the height is at the bottom. So we've got to check the scale first, and it seems like it's going up in 2s, so let's just check that. Yep, it's going up in 2s. So what I want to do is draw a line across at the width of 17, which will be roughly here. I'm going to stop when it hits the line of best fit, and I'm going to draw a line down, and I'm going to read off what that is. Well, this scale is also going up in 2s, I think. Yep, it is. So the estimate of the height would be 4 centimeters. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount or fraction of the food to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5 to 2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part is going to be worth, well, as a fraction it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction, and it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. In this question we're asked to draw the line y equals 2x plus 3. Now there's no x squared or x cubed, so I know it's going to be a straight line graph. Now there's multiple ways of doing this. I'm going to do it using a table, and then I'm going to show you a few other tricks of doing it much quicker or checking that you've got it right. The first number I'm going to start with is 0, and this, what I'm circling now, is going to be a coordinate to plot on our graph. So the top number, the 0, is the x, so this is when x equals 0. And what I'm going to do is I'm going to feed that into my equation. So when x equals 0, or y equals 2 times x, so 2 times 0 plus 3. 2 times 0 is just 0, so y equals 3. Now you don't need to do this working out for every single number, but I'm just doing it to show you how I'm getting to the y. So I'm going to try the next one without any working out. So we've got 1, and so 2 times 1 is 2, plus 3 is 5. Then the next coordinate, we've got x equals 2, so 2 times 2 is 4, plus 3 is 7. And the next one, we've got 3, so 2 times 3 is 6, plus 3 is 9. Okay, and I always go back to the negatives because I can kind of see a pattern with the positive numbers, so I can use that pattern to check that I'm doing this right. So 2 times minus 1, well, positive times a negative is a negative, so that's minus 2, and minus 2 plus 3, well, if I just use the number line, minus 2 plus 3, so 1, 2, 3 will be 1. And I can notice that they're going down in 2, so 9, 7, 5, 3, 1. So let's try the next one. 2 times negative 2 is minus 4, minus 4 plus 3 is minus 1. Minus 3 times 2 is minus 6, minus 6 plus 3 is minus 3. So those are my final two coordinates. The next step is to plot the coordinates on the graph. So my first coordinate is minus 3, minus 3. My next one's minus 2, minus 1. Then we've got minus 1, 1. Then we've got 0, 3. Then we've got 1, 5. 2, 7. And 3, 9. Now I want to join those up with a straight line. So let's do that now. And the last step is to label it. And sometimes you're asked to draw more than one line. So we should label it. There we go. Now, I can check that this is right because all of the numbers landed on the straight line. If I had one coordinate down here, I'd always check it. You're never going to have a straight line graph that goes up and then dips down, then goes back up again. Okay, so it's an easy way to check that you've got it right. Now, I said there was a quicker way of doing this. If you have a look at the graph, the equation, y equals 2x plus 3. This plus 3 tells us where it's going to hit the y-axis. So I can plot that one straight away. This 2 is a gradient. So if I go across 1, it tells us how far up it's going to go. And I just do that a few times to get 3 coordinates. And I can draw my straight line graph from that, and I don't need to put the table. But if the question asks you to fill out the table, obviously you need to fill out the table. Okay, so the main problem with this question is that people don't know what a frequency polygon is. If you know what a frequency polygon is, I think most people will get this right. Frequency polygon is basically a line graph, but you plot these at the midpoints. So the first one's going to be plotted at 40. The next one, so if you don't know how to find a midpoint, you just find the halfway value between 0 and 80, which is 40. To do it a different way, you could add the two values together and halve it, and that works just as well. So 80 plus 160 is 240, and then halve it would be 120. 160 plus 240 is going to be 400, halve it is 200. Okay, so we're going to plot these at 40, 120 and 200. Now a different way of doing it is just plotting them halfway between the two lines. So we've got a line here and a line here, so we're just plotting them halfway. So it says frequency is 11, so looking at the scale it looks like it's going up in 2s, so that would be 12, 14, 16, 18 and 20, so that works. So we're going to plot it halfway between the two red lines that I've just shown, and it's going to be halfway between 10 and 12, so it's going to be about here. And they're quite forgiving as long as they understand the point you're trying to do. If you're slightly off it, they are quite forgiving with that. Okay, so 120 is halfway between 80 and 160, and it's going to be 18 tall, which will be here. And 200 is going to be up to 6. So let's plot these 8, 6, 4, 2. And so 6 is going to be here. Now we haven't finished yet. We do need to join them up with straight lines. So let's just do that to finish off the question. And there we go. That is a frequency polygon. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it. And then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Now, a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question, you won't be able to guess it correctly, or it'd be very, very unlikely. So we approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assume they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and a way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good. And 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 on the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to 2 decimal places, that's going to be 7.53. Now, the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3. But chances are it will balance out that it's roughly going to be about 2 in that group, and 6 in the next group, and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. Okay, to start off, when you're working out the nth term, you've got to work out what the sequence is going up in. Now this is a bit weird, this one, because it's going down, but we've still got to work out what it's going up in, so it goes up by -3 each time, and you always check that it continues, which it does. This number then goes before the letter n, so it's -3n. The next step is you go backwards 1 and find out what the 0th term is. So the 0th term here is going to be 20, because 20 take away 3 is 17. And this we add on to the end here. So it's -3n plus 20. And always check it. So for the first one, n is 1. So -3 times 1 is -3, plus 20 is 17. For the 5th term, -3 times 5 is -15. -15 plus 20 is 5, which is our 5th term. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right-angled triangle here. So we can see there's a right-angled triangle here, and we know that when we've got right-angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be Ka, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47 and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens the set brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether. And there's 3 reds and 7 altogether. And that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7 and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them. So it's x to the power of 0. And we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do, so either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always, and 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So in your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89 and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny, because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to 917 pounds. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees. And there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826, blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator. I'm going to add 37 and add another lot of 37. So add 37, add 37. and that gives me 168.2826 blah blah blah. Once it's two decimal places, so line goes down here and we've got 168.28. Now just be careful that you add on the extra bits. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Now I'm going to be using the multiplier method for this question. If you've got a different method that works really well, then stick with it. But you do need to know the multiplier method for the GCSE. Now the word that probably tricks most people is this one here. Depreciates means goes down. Okay, it means it loses value. So it goes down by 1.7% each year. So to work out the multiplier, you first of all start off with 100%. Now this time you take away 1.7%, okay, because it's going down by 1.7%. You can do that on your calculator or in your head. So 100 take away 1.7 is 98.3%. Then you want to work it out as a multiplier. So you're going to do 98.3%. You just divide it by 100. And multiply is a posh way of saying decimal. So 0.983. Now anytime I times something by 0.983, it will decrease it by 1.7%. So we've got a car we bought in 1980, and what is it worth in 1985? So that is 5 years. So it's going to depreciate by 1.7% every year. So we've got the 2,245, and if we times it by 0.983 once, that's 1 year. But we need to times it by that amount 5 times. And instead of writing that times 0.983 times 0.983 times 0.983 5 times, I can just do it to the power of 5. You get the same answer. So in the exam, you can just write times 0.983 5 times, and that's absolutely fine. You get the same answer. So 2245 on the calculator times 0.983 to the power of 5. And I get the answer of 2060.553687 blah blah blah. Okay, so because it's money, it's going to be two decimal places, so that's going to be 55. Now last thing is just to check your answer makes sense. Well, the car was worth 2,245. It has depreciated, but not by very much. 1.7% is not very much. So it's gone down, and it lost about, say, roughly £200. So the answer makes sense. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side, and the upper bound is on the right hand side. And the lower bound's always here, and the upper bound's always here. Okay, so for this question, understanding of the formula of a circle is critical. So formula of a circle is x squared plus y squared equals r squared. So it looks very, very similar to the equation given to us here. So if I rewrite the equation given to us, and instead of 4 I write 2 squared. Okay, and that's a perfect match for the equation of a circle. So we've got a circle with radius 2. So it's from the origin, which is here. Let's do this in red so it shows up. And it will pass through, it will have a radius of 2. Now I don't have a compass, but when you're doing this, do it with a compass, and you're going to see how rubbish I am at drawing circles. That wasn't bad, although I think it's just going to get worse. It's probably the least pathetic circle I've drawn, but use a compass in the exam. Measure out the radius on one of the axes, and then just draw a circle, and that's 4 marks. Okay, so Boxplot question. Now, it might be tempting to think that the information here is all you need to plot on the Boxplot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other 2 that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done. Or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students, so I just need to find out 25% of 140, and I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5. That doesn't make much sense. So on this question, I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down, because you've shown that it's 17.5. Well, you can't get half a student, so let's go for 17, or let's go for 18. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4, 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach which I'm going to use is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it X, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine X over, so this is sine X, this is X here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine X equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So X is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that X is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that Y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as Y, just to make it a bit easier. So Y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that. Then I'm going to type in 180, take away the answer. So that tells me that y is 31.2104, blah, blah, blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it with A and B. A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104, blah, blah, blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455, blah, blah, blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got, say, 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. Now, this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population, and then you capture a few more again. And then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. N, which is the population size, that's what we're trying to find out, is this, it equals M. Now, M is the amount of things that you marked and then released. So on our example here, we marked 4. Times N. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here, it's 2. So let's apply this to the question. Let's try and work out what m is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, well, you often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2, and we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is, on the Casio calculators, you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it, and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. So what this question is asking us to do is find the inverse function. That's what the f to the power of minus 1 means. And there's a really easy way of doing this. If we rewrite the function as y equals 4x minus 5, to find the inverse of it, we just literally swap the y and the x around. So x goes here and y goes here. Then the task is to try and get the try and get the y equals. Okay, try and make y the subject. So I'm going to go put my lines down. So the first thing I need to do is add 5 to both sides. So we're going to have x plus 5 equals 4y. And next thing I need to do is divide by 4 both sides. And the way of doing that really is just with a fraction. So y is x plus 5 over 4. Now we made up y. Y represented the function initially, and then it represented the inverse function essentially. So all we need to do is finish that off. So f to the power of minus 1 of x equals x plus 5 over 4. If I just put that into the answer box. Now there are other methods, but I've always found just writing y equals and swapping the x and the y around and making the y the subject by far the easiest method. But if you've got a different one and it works, stick with it. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done. So we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. and 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers that add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3.
Okay, so this question seems really complicated because the just sheer amount of words, but actually it's quite a simple question when you get your head around it. So the first question, we're looking at a bag or 2 bags of letters and 1 bag of numbers. And so there are 26 letters in the alphabet, so there's 26 options for this first bag. There will be 26 options for the second bag, and numbers from 0 to 9. Now we've got to be careful here because 0 is counted, so there are 10 numbers in that bag, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's also 0, so that's 10 in total. And to get the amount of combinations, all we do is 26 times 26 times 10. And we'll have a calculator for this, so 26 times 26 times 10, which is 6,760, which seems quite a lot, but there we go. This next one is, so he wants to use 4 digits, but limit the combinations. So we just got to read the question. His letter bags now
contain the letters A to F, so that's A, B, C, D, E, F, which is 6. So these both will contain 6. And only contain even numbers greater than 0. Now, these are the same bags as before, so we only had the numbers from 0 to 9 before. So the even numbers that are greater than 0, so it's 2, 4, 6, 8. So there's 4 combinations. So there's 4 numbers those can be. And so find out how many different passwords if they're arranged like this. So 6 times 4 times 4 times 6. So 6 times 4 times 4 times 6, which is 576. Now, that might seem confusing that there's an extra digit to the password and yet less combinations. But if you think about it, there's significantly less letters and less numbers. So that's why it's a much lower number than part A. This seems like quite a complicated question, but if you break it down into steps, it's much, much simpler. We need to find out, first of all, what the area scale factor is. Now, it's important that you realise that there's a linear scale factor, an area scale factor, and a volume scale factor. To work out the area scale factor, I'm going to get the 1731, which is the new size, and divide it by the old size, which is 2328. So I'm going to get my calculator, and 1731 divided by 2328. And when I do that, I get a horrible decimal. Now you can write it as the fraction that turns up, which is 577 over 776. We can write it as decimal, but keep it in your calculator because the next step is to work out what the linear scale factor is. Now, there's no linear involved in this, but we need the linear one to then find out what the volume scale factor is. Now, to find a linear scale factor from an area scale factor, all you need to do is square root it. So I'm going to square root 577 over 776, or I've just kept it in my calculator. So what I'm going to do is press the square root button and then just answer, which is at the bottom of the calculator, bottom of the Casio calculators. Press equals, and it now gives me a decimal of 0.8622, blah, blah, blah. And when I do the little dashes at the bottom there, I'm showing the examiner that I'm going to keep it in my calculator. I'm not going to round it. Right, so we need to work out the volume scale factor. Now, to find the volume scale factor from the linear scale factor, you just cube it. So I'm going to show the examiner that I'm going to keep it in my calculator, but I'm going to cube it. So what I'm going to do is just press the X with a little square button, and then 3. Or just press the X cubed button. Let's have a look. And that's going to be 0.6411. And again, I'm going to keep it in my calculator because the last step is to find out what the new grams is. Now, the reason we need the volume scale factor is grams is a 3-dimensional thing. Okay, so it's going to be involved in the volume. Yes, with volume normally it's centimeters cubed, but grams works the same way as centimeters cubed. So to work out the new weight, I'm just going to get 319 and I'm going to times it by that 0.641 blah 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 blah. So on my calculator I'm just going to times it by 319 and I get the answer of 204.5322 blah blah blah. It says it wants its 2 decimal places, so 204.53 is going to be my answer. Okay, so we've got an exponential graph. The reason we know that is because it's to the power of x, and we're given 2 points on it. So the way I'd start this question is to just look at this point here and substitute in the values. So we've got 15 equals ka, right, to the power of 1, which is just a. Then underneath it, I'm going to write this one here. So it's 135 equals ka to the power of 3. Now I'm going to think about what I do to the right hand side here to get from Ka to Ka cubed. Well, I'm going to times it by a squared. So I think, well, what do I do to this side? So I get my calculator and I do 135 divided by 15, which is 9. So I'm going to times it by 9. Therefore, a squared must be equal to 9, because we're timesing the left hand side by 9 and we're timesing the right hand side by a squared. So we then square root that. Now this is where it gets interesting. You actually get a positive and a negative 3, but the reason I know it's positive 3 is because if it was a negative, the actual graph would look like this. So if it's a normal exponential graph, which this is, because this passes through 1 here, then it's going to be a positive power. If it's a negative power, it means it's a fraction, and therefore it will never quite get to the y-axis. But you don't need to worry about that. If this was us, it's normally going to be a positive, but having said that, it might not be. So anyway, I then use that a into the first equation, so 15 equals k times a, well that's going to be 3k, and then divide both sides by 3, and you get k equals 5. So k equals 5 and a equals 3, and I just need to check that. So let's do the second equation, so 5 times 3 cubed. So 5 times 3 cubed is 135, so I know I've got it right. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something, okay? Now, we've got 2x squared, and so minus something x. We've got 2x squared minus 28x, so we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, well, using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square, okay? So I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. Okay, so this is a question on iteration,
And we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now, the beauty of these calculators, these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. The first thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now, at A level, there are much easier ways of doing this, but we at GCSE have to do this using the trapezium rule. Now, the trapezium rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between them. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s, and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h actually using the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because A and B are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area. So this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.